Hello, my name's Jerry and this is part 7 in building my AK GT40. The next video that this is meant to be is where we determine the length of the push rods. But to determine the length of the push rods we have to assemble the engine, which includes head gasket. So I have to first of all calculate what thickness of head gasket I'm going to use. So there's plenty of programs on the internet for working this out, which I've got one here, which is an Omni calculator. And it's a very straightforward one. I've checked it against other calculators and they all come up with the same result. So this is how I arrived at the head gasket thickness I required. I was looking for a 10:1 compression ratio. Nothing really high and nothing very low. This is going to be a long-term project and one that I'm going to keep on the road. So not quite sure what's going to happen to fuels in the future. No doubt they're going to get crappier and crappier. So I don't want to go overboard on compression ratios. So I think 10:1 is a good place to actually build it for. So entering the information, this is how I arrived at the actual gasket size I needed. So we know it's an 8-cylinder. So you can see I've done that. Bore diameter, and we're working in inches. And the bore is 4 inches, but it's been overbored by 30 thou. So that's 4.03. The stroke, it's a stroker crank. So we're looking at a stroke of 3.4 inches. The head gasket thickness, I've already done various calculations and depending on what sizes are available. So I'm going to put in a 51 thou compressed gasket, which is going to be a multi-layer steel one. So I'll enter that as 0.051. Again, we're in inches. The actual bore of the gasket, although the engine is 4.03, the gasket comes in at 4.1 inches. So we'll enter that. Now, the deck clearance is the distance between the top of the piston and the top of the block. If the piston protrudes above the block, then it's negative. And if the piston is below the block, we have to enter a positive value. Now, as you remember on previous videos, I've measured this at 20 thou. So we will enter 20 thou and it's plus because the piston was below the deck. Now, combustion chamber volume, I haven't measured it, so I'm going to base it on the AFR supplied information, and they say it's a 58 cc. Piston volume, now here they want to know whether there's a dome on the piston or whether there's valve pockets, i.e. is it above or below. If it's above, i.e. it's got a dome, then we will enter a negative value. If it's got pockets for valves, so it's dished, then it's a positive value. Again, I'm going to go on what Eagle tell me in the information that accompanied the kit, and that is a 5cc, not 50, that's a 5cc, and it's plus because it's got cutouts for the valves. So that's all the information we need. Now if we come on down, it tells us the compressed volume and displacement volume, and obviously the volume of the engine is 5.7 litres basically, and it's given me a compression ratio of slightly over 10:1, which is my ideal size I need. I could get different thicknesses head gaskets, so I could get a smaller head gasket and that will obviously raise the compression ratio, or I could get thicker ones. So to give you an example how much it changes by just changing the head gasket, if I take the gasket from 051 to 061 and we come down and we can see the actual compression ratio is dropped to 9.8 because obviously we've got a bigger volume there. And if we change that to a 4, so it's a 40 thou gasket, then we're at 10.3:1. So compression ratio has gone up. The value I chose, the 5.1, that's easily available. So that's the size I should be using. So when I build the engine in the next video to do the push rod lengths, that's the size of the gasket I'll be using. This is a short video purely to show compression ratios. Thank you for watching.